7.1 is about random variables. You should already know the definition at the top. So a random variable associates a numerical value with an outcome of a chance experiment. We're going to learn about two types of random variables. The first one being a discrete random variable. All right, so the way these work, I'm going to draw a number line. A discrete random variable can only occur at fixed locations. So for example, if you have a random variable that can only occur here, or here, or here, but not in between the 2 points, that is a discrete random variable. So it can occur at many different locations, but those locations are isolated from each other. Usually you find these by counting. So usually they are a count of something. Now there are exceptions. So one exception I can think of is shoe size. So the length of someone's foot is not discrete, but the size that the manufacturer sells, well, that only goes up by half. So shoe size is a discrete random variable. All right, the other type is a continuous random variable. I'm going to draw another number line. So with a continuous random variable, the value can occur anywhere within a reasonable range. And I add the reasonable range part because a common inaccurate definition is that it can be anything, but we know that sometimes a really big number is impossible. So a continuous random variable can take on any value within reason. So it doesn't have to be isolated points. I think a good way to look at it is if it can be an ugly decimal, then it's continuous. If it has to be like a nice number, an integer, or only goes up by half or 0.1 at a time, then it's discrete. So usually you find a continuous random variable's value by measuring. All right, so we have 5 examples. Now would be a good time to pause the video, work on these, and then when you're done, resume it and check your answers. All right, so the number of broken eggs in a carton, that would be discrete. That could only be a whole number. So there can be 0 broken eggs, 1 broken egg, 2 broken eggs, all the way up to 12. All right, not sure how ozone is measured, but I would think this is continuous. So could the amount of ozone go up or increase by a very small amount, by a very small decimal? I would think so. So this should be continuous. The weight of a pineapple, that could increase by a decimal of a pound. So I would think this is continuous. The amount of time the customer spends in the store, could they stay in the store an extra 1/10 of a second or 100th of a second? Yes. So that is also continuous. The number of gas pumps that are in use, that is discrete. That has to be a whole number. 7.2 is probability distributions for a discrete random variable. All right, so there's kind of a long definition. Let me try to summarize it for you. So this term here, the probability distribution of a discrete random variable x, that is just a table or a chart that shows you every probability for every single possible numerical value of x. So again, we have a discrete random variable x, and it's discrete, so it can only take on some isolated number on a number line, usually an integer. And so it's a table that shows every single possible value and its probability. All right, so we have an example here. In this fictional city, you are allowed to have no more than 5 dogs or cats. We're going to let x be the number of dogs and cats in a randomly selected home. So is x discrete or continuous? That is discrete. We cannot have a decimal of a pet. What are possible values of x? Well, that would be every integer from 0 to 5. So those are the possible number of pets that someone could have at their home. All right, so we see the table. So it shows the probability of each possible value of x. So that's called a discrete probability distribution. And then the histogram below it is also a discrete probability distribution. That's just in a All right, so we have a couple pretty easy questions. So this lesson is just showing you the basics, and then for your homework you'll have slightly more challenging applications of these concepts. All right, so what is the probability that a randomly selected household has at most 2 pets? So it's really important that you read the wording carefully. So at most 2, that means 2 or less. So I'm going to use probability notation, probability of x being less than or equal to 2. All right, so because they are discrete, that means they're disjoint. You could either have 0 or 1 or 2 to satisfy this probability. So we're going to add them because remember, or means add. So the probability of this would be 0.26 plus 0.31 plus 0.21. And the reason being they could have 0 pets, 1 pet, or 2 pets. So or means add. 26 plus 31 plus 21, that would be 78, so 0.78. All right, next question. What is the probability that a randomly selected house has less than 2 pets? So notice the subtle difference. So this does not include having 2 pets. So we're just going to add 0.26 and 0.31. So the answer to this one is 0.57. All right, we have one more question. So this is kind of a preview of a future lesson. So notice that if we remove the option of equaling to, that it changes the probability. When we learn about probability distributions for continuous variables, when we learn about those, it won't matter if you include or you don't include the number. But for discrete, it does matter. Last question, we want to find the probability that we have more than 1. So we're not allowed to equal 1. But no more than 4. So no more than 4 means less than or equal to 4. So again, it's important that you read the wording. We are not allowed to equal 1 because it says more than 1. But what does not more than mean? Not more than means less than or equal. All right, so the numbers we're allowed to have are 2, 3, and 4. Probability of 2 was 0.21. Probability of 3 was 0.13, and probability of 4 was 0.06. 34 plus 6 is 40, so our probability is 0.4. Okay, that's it for 7.1 and 7.2.